All right, here we go. Biconditional statements. So the definition of a biconditional statement is that the conjunction of a conditional and its converse. So remember, we talked about conjunction. We said conjunction was an and statement. We know a conditional is if-then statement, and we know the converse is where we switch them, right? Switch P and Q. So this is the symbolic form, means that if P then Q and if Q then P, right? So we're going to read a biconditional as it goes both ways. So look at my line. I have a line in between there. Both P and Q have to be true. And we read this as P if and only if Q. So biconditional statements are true when both the conditional and converse are true. So remember, this is the conditional statement, if P then Q. This is the converse, if Q then P. And means that both of those have to be true. Make sense? All right. So the conditional and converse both have to be true. So here's my example. Given the biconditional statement below, I'm going to write the conditional and converse and then determine the truth value. And then, of course, if it's a conjecture, and then I have to give a reason why it's not true. So two angles are supplementary. Here's that word that makes it biconditional, if and only if the sum of their measures is 180. So if I want to turn this into a conditional statement, I would say if two angles are supplementary, then the sum of their measures is 180 degrees. That's the conditional, if then. So I'm going to put if P, then Q. Now the converse is I switch them, if Q, then P. So now I say if the sum of angles is 180 degrees, then they are supplementary. Both of these statements are true. So the truth value is true. Both statements are true. Two angles are supplementary. If then the sum of their measures is 180, and if the sum of the measures is 180, then they are supplementary. Both of those are true, so my truth value is true. All right, let's look at number 2. I wear snow boots if and only if it snows. So my conditional statement, remember, is if P then Q. So if I wear snow boots, then it snows. If P then Q. Converse says if Q then P. So now I'd say if it snows, then I wear snow boots. Well, I'm going to go with false on this, because if I wear snow boots, doesn't mean it's going to snow. What if the snow boots are really cute and I just like how they look and it's not snowing outside? So it's false because of my conditional is false. All right, let's look at number 3. X squared equals 25 if and only if x equals 5. So if x squared equals 25, then x equals 5. My converse switches them. Says if x equals 5, then x squared equals 25. And that is a true, no. That's totally false. That's totally false, because what if my converse, well, if my conditional, false. Look at my conditional. Conditional could be x equals negative 5. Then that would make it not true, because negative 5 times negative 5 equals 25. This one's true. If x equals 5, then x squared equals 25. That's true, but my conditional is false. So it makes it not true. Almost stumped me on that one. All right. So that should help you with how to write those into if-then statements and then see if they're biconditional. All right, look at this next one. Mind your P's and Q's. So I'm sure you were tired of me talking about P's and Q's, but we're going to look more at compound statements. So remember, a compound statement is and, caret top up, and or, caret top down. So I'm going to use the statements below to write the compound statements. So P, vertical angles are congruent. Q, 15 is a prime number. So a conjunction is an and statement. So it says if P, then Q, right? Both are true. So vertical angles are congruent. Vertical angles are congruent. And 15 is a prime number. The truth value there is false. False. 15 is not a prime number. 3 and 5 are divisible by them. So remember, an and statement, both of them have to be true. A disjunction says P or Q. So now I can say vertical angles are congruent, or 15 is a prime number. Remember, only one of them has to be true. And yes, vertical angles are congruent, so my truth value here is true. Okay? So, now let's look at conditional statements. Conditional statements, it's all of them. So, my condition is if P, then Q. Remember, my inverse is making it opposite, so if not P, then not Q. My converse is switching them, so if Q, then P. And my contrapositive is I'm negating my switch and flip, all right? And then my biconditional would be P if and only if Q. All right, so let's take a look at these and look at the truth value. So if it is St. Patrick's Day, then it is March. And yes, that is a true statement because St. Patty's Day always holds true in March. So, look at my inverse. If it is not St. Patrick's Day, then it is not March. Well, that is false because what if it's March 3rd? So that could still be March. So my converse says if it is March, then it is St. Patrick's Day. Not true, because again, it could be March 3rd. So that is false. My contrapositive says, if it is not March, then it is not St. Patrick's Day. Well, that's true. If it is not March, then it is not St. Patrick's Day. Very true. And my biconditional statement would say, it is St. Patrick's Day if and only if it is March. It is St. Patrick's Day if and only if it is March. That's not true. Because again, you could have March 3rd. So that's how I'm writing my conditional statements, and then I'm establishing that truth value. So if you're still struggling on, minding your P's and Q's, come and see me and I can help you with that. Good luck.